So given RT, RT is congruent with WX, which statement is true? So it says here, okay, so let's let's break this down into 4 different things. So A is RT equals 2RX. B is RT plus TW equals WX plus TW. C here is WX equals 2RX. And D here is RT plus TW equals RW. Okay, so let's look at number 1. So number 1 states that RT equals 2RX. So let's look at RT here. RT is here to here equals 2RX. So RX would be from this point to this point here. So let me just redraw this trapezoid actually. Let me redraw this trapezoid. So this is R, this is T, S, X. This here is congruent, or let me do a blue. This here is congruent with this side here. This here is W. This here is V, and this here is U. Okay, so we have our 4 points here. So this is RT. So RT, so between this point, just in red, between this point here, and this point is 2RX. So between this point and this point here, RX, right? So from this point to this point. So if I bisect this this trapezoid, does that equal this? And in this case is false, right? Because I don't know if RT and WX I don't know if this point to this point is halfway through the trapezoid. So in this case, A is incorrect here because I don't know if T is halfway through the trapezoid. And again, even if it was here, if it was halfway in this case, this total length here, because it's a trapezoid. So remember, if this here is my trapezoid here. There's 2 triangles here. I'm gonna have to take the length between this rectangle in the middle, and I would have to justify between this distance and this distance. So these 2 is not equal to 2RX. Let's look at B. B is RT plus TW equals WX plus TW. So RT, which is, let me erase this now. RT. So I know this is wrong. A is wrong. So I know that RT is this side here, and TW is this side from here to here equals WX. So from here to here and TW. So this here, this here. So in this case, B is correct. No one's perfect also says B is correct, and that's correct, right? Because I know that RT and WX are congruent with each other, and TW is the exact same like from here to here, right? DTW exists on both sides, right? So if you look at this algebraic equation, TW and TW are the same side, so you can actually cancel them out. And RT equals WX, and we know that RT here is congruent to WX, which means that this here is our correct answer. So B is our correct answer. I'm going to prove to you that the C is false too. So let me erase these guys here. So WX equals 2RX, so WX is here, and 2RX would be, 2RX is from here to here, right? So from this point to this point, and again, I told you that if RT, this is the same, the A and C have the same logic here. It's still 2RX here, and RT equals WX, right? So this here is also false, right? Like I said before, well, if we bisect, or if this length from R to X is not 2 times WX, right? Because I know that, again, this here is a triangle here. This here's another triangle. I would have to justify for the length of the diagonal of the rectangle plus the length between the side to the tip of the triangle. So this here is incorrect as well. So it's the same logic as A. And then let me do D as well. Let me, oh shoot, don't want to erase that. Let me do D as well. Okay, so D here says that RT plus TW is RW. So RT would be this length here, TW is this length here, and RW would be this length here. So let me see, so this length here equals this length plus this, wait, plus this length, right? So in this case, that's not correct, right? Oh, shoot. Can't even draw the triangle properly. So it says here, oh, actually, I'll do this in red, or blue, sorry. So RT is here, and TW is here, right? It has to equal RW, which is the red. So the blue has to equal the red. And again, in this case, this does not make sense, right? Again, I don't know anything about the lengths of these triangles. Even if it was a right triangle, I would have to have the format c squared equals a squared plus b squared, right? To solve for my lengths. So in this case, D cannot be correct also, which means B here is the only logical answer in this case. So no one's perfect. Awesome. Thanks for tuning in, by the way. So it says here, A is false, twice the length would be greater than the length. That's like we proved before. Option C is also false, and we said option B is correct, right? So we know that, and we can actually use algebra to kind of figure that out, because TW exists on both sides, so I can bring TW to one side, I cancel both of those terms out, and get RT equals WX, as stated before. D is also false. Consider the triangle RTW. RT plus TW is greater than RW, right? And addition of lengths of any two sides is always greater than the length of the third side, right? So exactly the same concept as if I had a, and this kind of has, I have any triangle here. Let's say this 1, 1, and root 2. If I add these sides together, the horizontal and the vertical lines here, 1 plus 1 here is 2, right? And 2 here is greater than root 2. And you can prove that root 2 is like root 2 is like 1.4, something like that. So again, any two sides, addition of any two sides is always greater than the third side. So D here is also incorrect. So this here is my solution. B here is correct. This is great logic and solution. So this here is also correct.